Good morning, everyone. I'm Dr. Karin. I am going to give a lecture today on lipid chemistry. So these are our objectives for today. We will define lipids, enumerate the different functions of lipids, give the different classifications of lipids. You need to understand the nomenclature of your fatty acids, and also we will determine other lipids and its characteristics. So we will define lipids. So they are organic substances which are relatively insoluble in water, but soluble in organic solvents like your chloroform, ether, and benzene. So if you look at the structure of a lipid, there are three major elements in the form of carbon, hydrogen, and oxygen. And the smallest molecules used to make lipids are your glycerol plus 3 fatty acids. And this glycerol is a colorless, gunky liquid, sometimes called glycerin. So this is your glycerol. If you notice, you have the three major elements and it has 3 carbons in it. So if you are talking about acids in biological chemistry, if you see structures of or having a carboxyl group in its end, then you are dealing with an acid. And a fatty acid are acids with very long hydrocarbon chains attached to it. So this is an example of an 18-carbon fatty acid. So look at this. You have a carboxyl end, the COOH, and on the other hand, or on the other side, there is a methyl end comprising, which is composed of CH3. So with regards to characteristics of a fatty acid, it is unbranched. And in humans, most often it's even number of carbon atoms. You can find odd number in ruminants and in animals. And when double bonds are present, it is usually in cis configuration. So if the acyl chains are on the same side of the bond, it's cis. And if it's on the opposite side, it is trans. So trans fatty acids may arise as byproducts of the saturation of fatty acids during hydrogenation, and it is associated with increased risk of cardiovascular diseases and diabetes mellitus. So this is the process of hydrogenation. Now wherein this one, the double bond here, is become saturated with hydrogen molecules, making it a trans fatty acid. In an average individual, in a normal individual, we do have an average daily intake. So the bulk of our diet must be provided by carbohydrates. Okay, that's about 50 to 60%. And then 30 to 35% will be coming from fat. And the combined saturated fat and trans fat intake is limited to 10% or less of our daily calories. So it should not go beyond 10%, okay, in relation to the consumption of saturated and trans fat intake. Okay, we do have several terminologies. So when you talk about long chain fatty acid, you are dealing with a fatty acid containing 12 to 26 carbons. And a medium chain fatty acid has 8 to 10 carbons. And then the shorter chain fatty acid has 4 to 6 carbons. Okay, let's proceed now to the classification of lipids. So it is being classified simple, complex, and derived lipids. So simple lipids are esters of fatty acids with various alcohols, no? Depending on the type of alcohol, they are esterified and they are being subclassified as neutral fats or oils or waxes. So when you say neutral fats or oils, that is the alcohol, there is your glycerol. Whereas in waxes, the alcohol there is other than glycerol. So waxes, these are examples of your waxes. They are esters of fatty acids with higher molecular weight monohydric alcohols. Okay, let's proceed to complex lipids. So these are esters of fatty acids with alcohol containing additional groups. Meaning to say you have a lipid and a non-lipid component. And they are subclassified according to the type of prosthetic group. Like your phospholipids, the glycolipids, and the lipotins. So phospholipids, they have the fatty acid there. Glycerol as the backbone. And what is characteristic here is the presence of phosphoric acid and they frequently have nitrogen containing bases. So these are your phospholipids. Here you have your glycerophospholipids, the sphingolipids, which are very important in the developing brain. So phospholipids are the main lipid constituents of the membranes, and these are the examples, no, of your phospholipids: the phosphatidylcholines or your lecithin, the ethanolamine or your cephalins, the phosphatidylinositol, and the diphosphatidylglycerol or your cardiolipin. Okay, so these are your phospholipids. So phosphatidylcholine, they are the most abundant phospholipids of cell membrane. And they are very important in nervous transmission, okay, the form of choline, and as a very important constituent of the lungs, particularly in the surfactant. Okay, they would serve as surface active agent. Next, you have the phosphatidylinositol. They are precursors of the second messengers. So they would provide internal signals. Okay. And then your diphosphatidylglycerol, they are the major lipids of the mitochondrial membranes. Okay. So next we have the glycolipids. So they are also very important constituent of the nervous tissues. They contribute to the cell surface, okay, here, no, in the outer leaflet of the plasma membrane. So they are the surface carbohydrates. So you have your galactoceramides, glucosylceramides, and your gangliosides. So these are the examples. Okay, so it is a fatty acid with an alcohol, particularly the sphingosine, and a carbohydrate with nitrogen base. So galactosylceramides, they are major glycolipid of the brain. And then the glucosylceramides are found in the extraneural tissues, and the gangliosides are found in the nervous tissues also. And the complex sphingolipids derive from glucosylceramide plus the sialic acid. Okay, so this particular fatty acids are very important in also in a developing brain. The third classification are your derived lipids. So they are also called precursor lipids. So examples of which are your fatty acids, the steroids, cholesterol, and some of your vitamins like A and D. Okay, let's proceed to the types of fatty acids. So you have unsaturated and saturated fatty acids. When you say unsaturated, there is presence of a double bond. If there is one double bond present, it's monounsaturated. If there are two or more, then you call it polyunsaturated. But if the carbon molecules are fully saturated with hydrogen molecules and there's absence of double bond, then you are dealing with a saturated fatty acid. There is a third type of fatty acid, okay, in the group of eicosanoids containing 20 carbons. It is a 20 carbon polyenoic fatty acid. And these are precursors of your prostaglandins, the thromboxanes, leukotrienes. Okay, so your arachidonic acid is the precursor of which. So this one is a saturated fatty acid. If you look at the structure, if you look at this one, there are no double bonds present. All the carbon molecules are saturated by hydrogen. And this one with the presence of double bond. So this is a polyunsaturated fatty acid. Okay, so we have essential PUFAs. So there are two major essential PUFAs, your linoleic acid and alpha linolenic acid. Okay, so if you see here, there is a symbol 18-2. Okay, 18 would mean 18 carbons in it, and 2 would mean presence of 2 double bonds. Okay, so this one is a polyunsaturated fatty acid. And this one, this symbol would mean omega. Okay, so your linoleic acid is an omega-6 fatty acid. Whereas your alpha linolenic acid, it's also an 18 carbon fatty acid with 3 double bonds, and it is an omega-3 fatty acid. Okay, so they are very important for proper membrane structure. But if the diet of an individual lacks linoleic acid, okay, or if the linoleic acid is insufficient, then the third essential PUFA will be your arachidonic acid. But it is not an essential PUFA if you have enough linoleic acid in the diet. Okay, so if you look at this structure, so this is your linoleic acid. So it has 2 double bonds. And then your alpha linolenic acid has 3 double bonds. And here, this is your carboxyl end, and this is your methyl end. So we will go back to this structure later when we will designate your fatty acid. Okay. So I'm showing you now the sources of your fats. So if you notice the unsaturated, both the mono and polyunsaturated fats, the main sources are your plants. Whereas the saturated fats, it can be sourced from the animals. Okay, so this table would show common biological saturated fatty acids. So these are examples, your lauric, myristic, palmitic, stearic, arachidic acid. So look at the symbol. If you see like this one, so you're dealing, if you have the 0 there, then definitely you're dealing with a saturated fatty acid. 0 means no double bond present. Okay, whereas this one, your unsaturated fatty acids, so you have these different symbols, but as you look at it, there are delta symbols. Okay, look at the alpha linolenic acid. So you have 18 carbons, 3 double bonds, and then you have delta 9, 12, and 15. So what does it mean? So the 9 would mean that the location of the double bond is on the 9th carbon from the carboxyl end, 12th and 15th. Okay, let's go back to a structure of your alpha linolenic acid. Okay, so you count the delta designation, you need to count from the carboxyl end. So here, the first double bond is located on the 9th, next on the 12th, and the third one is on the 15th. And when you designate a particular fatty acid with regards its omega, so you need to count the double bond from the methyl end. Okay, so this one, the first double bond from the methyl end is located on the third. So that's why alpha linolenic acid is an example of an omega-3 fatty acid. Okay, so we will now classify. So this is just a short activity. No, I will just teach you how to classify your fatty acids on the basis of their structural characteristics. The first thing that you will do is you need to designate your fatty acid, whether your fatty acid is a short chain fatty acid, or a long chain polyunsaturated fatty acid. So that's it, no? And then afterwards, you will identify its shorthand designation based on the carbon chain length and the degree of saturation. Like for example, your linolenic acid, no? So you will put 18 because there are 18 carbons present, and then 3 because there are 3 double bonds present. Okay, and the next is you identify which omega family does it belong and what is the delta designation for the carbon chain double bond location. Okay, so let's have this. Okay, so if you look at this particular structure, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 meaning to say you are dealing with a long chain fatty acid. How about the saturation? There are 2 double bonds, so therefore this is a polyunsaturated fatty acid. Okay, so the type designation here is a long chain polyunsaturated fatty acid. Okay, the next is what is the numerical shorthand designation, no, based on its carbon chain length and degree of saturation, no? So as we counted earlier, it's an 18, okay, and it has 2 double bond, so 18, 2. And here, what is the location? So here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the first double bond on the 9th carbon, and then the second double bond on the 12th. So it's 18, 2, delta, 9, 12. Okay, so what omega family does it belong? So 1, 2, 3, 4, 5, 6. So it is omega 6. So therefore, this is your linoleic acid. Okay. So let's proceed, no? So we will enumerate now the functions of lipids. So aside from making our food palatable, making it more yummy, okay? So there are a lot of functions of lipids other than that. So it is a storage form of energy. It provides structure, no? It is a very important structural component of the cell membrane. It's a precursor of many hormones, particularly your steroid hormones, would act as thermal regulators, insulators, and it protects internal organs. Also from lipids, so there would be formation of bile acids, which would help in the absorption of fat-soluble vitamins. The lipoproteins itself would serve as lipid transporters. Okay, and then we've mentioned earlier about the phospholipids. So they would act as surfactants by reducing surface tension, so improve food taste and even medication palatability. And finally, act as electric insulators in the neurons. So there are also physical properties of fatty acids. So this is largely determined by the length and degree of unsaturation of the fatty acid carbon chain. Okay, so the first physical property is the water solubility. So the shorter chain fatty acid have slight solubility in water compared to the long chain fatty acid, because the long chain fatty acid, the nature of its structure is very non-polar, because of its hydrocarbon chain. So that chain completely dominates its solubility. So you can compare. So glucose relatively has a very high water solubility with this, okay? And then this one, you have two fatty acids, the lauric and the stearic acid. Lauric acid is a shorter chain compared to stearic acid. So you can say that if you are given, if you just have this value on water solubility, you can say that you are dealing with a fatty acid that has a longer chain or has a shorter chain. Okay. The next physical property is the melting point. So as the carbon chain length increases, the melting point also increases. And this is due to the greater intermolecular attractions between fatty acid molecules. So therefore, the greater the degree of unsaturation, the greater will be the reduction in the melting points. So therefore, the longer chain saturated fatty acid in the form of like butter, margarine, no, they may remain solid at room temperature. The long chain unsaturated fatty acids like your olive oil may remain liquid at room temperature. So that is because of the decreased molecular attractions between the carbon chains. Okay, so I will just mention here about this triglycerides. So I just want to emphasize that the major storage form of fat in the body is the triacylglycerol. Okay, and they are esters of the trihydric alcohol, glycerol, and fatty acid. Whereas your cholesterol, they are the best known steroid. They are a major constituent of the plasma membrane and of plasma proteins. And they are precursors of large number of steroids, like your bile acids, adrenocortical hormones, some sex hormones, vitamins A and D, and some of your cardiac glycosides. So this triglycerides, this cholesterol will be mentioned in our future lectures. Okay, so we will have actually different topic. Okay, it's a different lecture topic. Okay, for this particular for cholesterol and your triglycerides. Okay, let me share to you the sources of dietary cholesterol. So when you say richest sources, so the richest are the egg yolk, the shellfishes, and of course mayonnaise. The main component or main ingredient is your egg yolk. Moderate levels on fats, milk, your ice cream, the cheeses, butter, your pastries. So there are moderate levels of your cholesterol. More source for all fishes. Fishes who are the preserved fishes in vegetable oil, like your tuna in vegetable oil, the very lean meats, poultry without the skin, the skimmed milk, low-fat yogurt, and cottage cheese. So poor source of cholesterol. And all vegetables, of course, all fruits, no, that includes avocados and olives. Same with the durian, okay? They are all cholesterol free, okay? Including the nuts, rice, egg white, and sugar. But even if you eat a lot of fruits, okay, some of this, the sugar coming from these sources may eventually form into cholesterol. So you will know how this glucose will lead to the formation of cholesterol. Okay. So I think that ends my short lecture on the general characteristic, no, the characteristics of your lipid, no? Everything about the chemistry of lipids. Okay, so thank you so much for your kind attention.